Hey folks, welcome to day 3 of SigNoz launch week. Today we are pretty excited to launch our new feature, which is first of its kind in the industry, and our developers and engineers have really worked hard to bring this to our community. And I have with me Shivanshu today to talk more about that. So welcome Shivanshu. Talk to us about, so we are today launching the messaging queues feature, and in that we are first doing Kafka and Celery, and it's pretty exciting to see how we have leveraged the OpenTelemetry semantic protocol on bringing some new innovations here, and Shivanshu have worked really hard on this. So Shivanshu, talk to us about what was the thought process behind this feature and what went through in building that, and maybe give a quick overview of that.
Sure, everyone. So I think from our customers, we have seen that it's very hard in distributed systems to figure out bottlenecks whenever there is some messaging queue involved. Because usually if your applications are not instrumented, the trace context is lost due to messaging system. But we are now leveraging OpenTelemetry semantic conventions to correlate all the producer and consumer spans with corresponding Kafka metrics. So it gives them very out-of-the-box insights into what's happening at queue at partition level. So you could see what's happening in your managed Kafka at a given topic at a given partition. And you can derive some information like when do you want to scale your consumer groups, which broker or which partitions are unhealthy. And then you can do a lot of correlations from the native Kafka metrics and the spans.
Yeah, so can you give us a quick overview of what does the different components of the systems look like? And then I would love to see a quick demo on what's the features and the key capabilities there.
Sure. So let me start with a quick overview. So typically, this is how it works. You have Kafka running with different topics and brokers configured, and you have producer and consumer services reading and writing from it, and you can enable OpenTelemetry collector with JMX matrix and Kafka matrix receiver and send everything out of the box to SigNoz. So we will go through how you can do the correlations in the product. So in the product, we have introduced additional tab messaging queues where you can quickly go over all of your messaging systems. So for example, here I can see one consumer service is writing to topic 1 of Kafka, and I can quickly go over the details of that particular combination of producer and consumer service. But we can also dive deeper into the messaging queue itself. So for example, if I want to take a look at my consumer group lag, I can just go there and take a look at a given spike, what all producer services are writing to it, what is the throughput P99, what is the consumer group, and what are the consumer services reading from it, what is the network fetch latency for that particular consumer instance reading from that consumer group topic and partition.
So this is all powered through the semantic convention of OpenTelemetry, right? So when applications are sending data, are you primarily leveraging traces here, or how does this get powered?
So basically, in a traditionally today, people are looking at the metrics that are being collected from Kafka, right? And these are native Kafka metrics, which are exposed as MVs from the Kafka JMX server. And then you can use any JMX receiver to see the metrics. But these metrics, which are coming from Kafka broker, does not have correlation with corresponding spans from producer and consumers. So there are two parts of it. One is the native matrix collection, and then the trace collection and correlation. So today we have metrics from Kafka and all the products out there. But what we are also doing is we are correlating that with the spans collected from OpenTelemetry instrumentation. So for example, if you are using Java or any other language, you can enable OpenTelemetry auto instrumenter for that, and it will generate all the spans, and then we correlate that with the metrics collected from Kafka brokers.
Got it. So for anybody who has, for example, instrumented their Java application and is using Kafka, this will get populated automatically. Or
Yeah, so that's one thing, because otherwise you would need to like create some dashboards, and probably those correlation wouldn't work. But if you are OpenTelemetry native and you use messaging queues and SigNoz, all these fields are out of the box populated.
got it. So what would this help consumers to like suppose they see that data that, hey, like consumer lag is high, and I see a couple of metrics or like services here. What do we do this with this data now?
Okay, so for that, let's take an example. So today, let's say if I am monitoring Kafka, I would see, okay, there are some spikes in my consumer group lag, and I would know which group partition and topic it belongs to. But these metrics does not give me any information about, do I need to auto scale my consumers at this point, or what's exactly happening from the producer and consumer, like from the frame of reference of a producer and consumer. And probably you could go and build some dashboards, but here you can quickly get that information. Let's say if you click at this any given spike, right, you can get all the services that are writing to that particular consumer group topic and partition, and what is the corresponding throughput, error rate, and P99. So you know, okay, at this point these two producer services are writing to it, and the consumer services that are reading from it, and their corresponding throughput, error rate, and average message size. This helps in understanding whenever there is a spike in consumer group lag, what is the throughput of my consumer services, and it can give insights like, do I need to increase my consumer services or fine tune how to auto scale them?
Got it. Got it. So, for example, I think I noticed in this example, there are two producer services we have which have around 35 RPS throughput, and then there's one consumer service which has around 69. So they are well balanced. So if I am assuming there's something wrong, either we will see high error rate in one of the consumer services, or like say higher P99, and through that you can immediately identify that, hey, like this is the culprit and like we should scale this service, rather than trying to figure out what's happening and then spend a lot of time. So this should, from what I can understand, help debug issues much faster, especially around messaging queues, right?
Yes. So in a if you are using Kafka at a scale, it becomes very hard, because Kafka in that context becomes a black box, right? Because there is no correlation between producer and consumer and the metrics from Kafka. So this becomes very handy in figuring out those bottlenecks.
What are the other features which you have built around Kafka? I see you have network latencies, there's a drop rate view.
Yeah. So let me show around the overview part first. So for example, when you start using this messaging queues with SigNoz, you can just get all the messaging queues that you are using in your system if you are using OpenTelemetry instrumentation for the applications. And then you can have a quick view on the service health, request rate and error, and P99 for every producer and consumer combination. And from there, you can dive deeper into Kafka. We have 5 different views for Kafka. One is consumer group lag, which we just talked about. Another is metric view, which gives you the out-of-the-box metrics. Another is in the consumer group lag itself, you can go and look at this network latency. So these are some correlation that we are doing with the matrix and spans. And let's say you want to look at what's happening at a given partition and a topic combination, right? So what is the throughput for that topic and partition? What is the P99? You can go and look at partition level details for that. So in this given example, we have topic 1, partition 1. And these are the producer and consumer services reading and writing to that at a given time. Similarly, we have a producer latency view where you can get the corresponding topic and partition details, in the sense which services are writing to which topic and what is the P99 for per partition. And we also have a drop rate view. So it's an interesting feature because let's say like for past 1 hour, you want to see what all message um, like took more than 10 milliseconds to consume, right? So here you can see those spans, those traces in a like single view. So there are, let's say, producer service one, which is writing to Kafka, and then we have consumer service one, which is reading, and all there were 358 spans, out of which 17 spans took more than 10 milliseconds to process. And you can then go to the corresponding trace IDs. So this helps in understanding how much time is being spent by every message in Kafka.
And by changing the evaluation interval, you can see, like, say in 50 millisecond, how many messages are passing, and in say 10 millisecond, how many messages are passing, right? So you sort of give a SLA guarantee to your customers internally.
Yes. Okay, let's dive deeper into the consumer group lag view, because I think that's the most important feature. So okay, I see for this particular point, which is consumer group 2, topic 2, and partition 0. Okay, I know these producer services are writing to it. These consumer services are writing to it, and the corresponding error rate and throughput. But one good thing is network latency here. So this network latency, this is a metric which comes from broker, but what we are doing is correlating that with spans. Meaning, you would know what exactly is the network latency for a given consumer instance with this correlation. So, for example, in this particular example, these consumer services are consuming from Kafka, and this is the corresponding network latency for that service.
So this information is not available in any other product, right?
Yeah. So this network latency, it is basically the Kafka native metric, but what that does not provide is correlation with the spans. So I would know the latency is this, but I wouldn't know what consumer services are correlating for that latency, like basically contributing to that latency. But what we are doing is we are correlating the consumer spans, aggregating during that time duration, and correlating that back with spans. So we know, okay, this is the latency because these are the services writing to that particular consumer good.
Yeah, so I think this is very interesting. So essentially you are able to correlate from like the metrics which is generated by the Kafka and the traces, and sort of we are trying to aggregate that and then come up with this latency metric, right?
Yeah.
Yeah, so that's I am sure our users will find this very helpful.
And like one more thing, if you are using Kafka in, let's say, StreamZ or Confluent Cloud or in Amazon MSK, you can directly use SigNoz to instrument your Kafka messaging queues because we support all these platforms. And let's say there's one more queue, Celery. Yeah, so Celery is one of the most commonly used queues. So today, like everybody is using Python for like orchestrating their agents and building their LLM applications, and that's where we are also seeing very like high demand of messaging queues like Celery, because those are Python native messaging queues, and that's why we have built the Celery integration as well. Here you can, in a single pane of glass, see how many workers are there, how many tasks are getting executed per worker, what are the tasks that are running inside inside your Celery. So let me take a look at this one. So there are total 1544 tasks that are running for past 1 hour, and these are the state of different tasks. I also know what are the corresponding workers, and these are the P99, P95 latency for every individual task. I can select, okay, I want to see the details for a given task. Then I can go ahead and see what are the tasks per second by worker, error percentage, throughput. Uh, that's also inbuilt. Okay, if I want to take a look at a given particular time, what all tasks are being run by a given worker, I can take a look at this panel just by clicking on that point, and then I can see the corresponding traces. So this helps in quickly understanding your health of queues and understanding the task status.
So all this is derived directly from the OpenTelemetry convention, right? So if you are using OpenTelemetry instrumentation Python for a Python app, does this automatically get populated, or do you do need to do something specific for Cell?
No, so basically if you are using any Python application and you are using OpenTelemetry instrumentation, this is all powered by spans, so this comes out of the box.
Got it. So this is very interesting. So we are able to provide new views to customers just out of the box. So all this data, of course, is very interesting. And many times we know that messaging queues are the sources of error. So now you can just come to this tab and be able to see all the details. And you can also see things like, hey, like, okay, for these tasks, which are the slowest tasks, and then dive directly to the trace detail and like figure out what's going wrong there. So a broader thing which I'm seeing here is that the OpenTelemetry semantic convention, which is the innovation from OpenTelemetry, we are deeply leveraging it to bring new features and insights to our customers. So I think that's something very interesting, Shivanshu, I think, which we have been able to achieve. Cool. So this sounds pretty interesting. What are you seeing? Like, what are typical use cases you see for such messaging queue? Maybe if you can share with an example or something which people can understand.
Yep. So messaging queues are being used widely. We ourselves use messaging queues for our ingestion. And let's say, let's take an example of maybe Uber. So if you are booking an application, like if you are using Uber to book a cab, right? Basically you go and book a cab, and from there you can see, let's say at a given point there are 10,000 users that are looking for a cab, right? Those requests Uber in-house would pipe that into Kafka, and then there would be consumer services that would process those events. But if there is a lot of network congestion and there is a lot of events that are generated and stored in Kafka, you would probably want to understand the delays that are happening from the consumer service, right? So that's where you can use the product end to end, understand the bottlenecks happening at your queues.
Yeah, and I think as more and more things get into event-based architecture and more jobs-driven architecture, I think this would be more and more interesting to our users. So, what is next in this future? Like, what are the roadmaps? What are the main type of use cases you are seeing from the community?
So there is a lot of traction. When we presented this in KubeCon, there were many people who were able to relate with the product. And now that we have launched it, there's demand coming for SQS, which is another queue, and some language support for different frameworks where you can use Kafka. So for example, today it works very well with Python and Java, but we are also seeing demand for .NET. Yep. So we are going to support more queues and be able to support it for different languages as well.
This sounds pretty interesting. I'm sure people would love it. Any last words for the community and like the audience who are listening to this launch week?
I think try it out. I mean, this is if you are a user which are using Kafka or Celery at scale. And if you show this to your DevOps people and show this to your like people who are managing infra, they would love it because you never know, like Kafka in distributed systems or any messaging queue in a distributed system sort of becomes a bottleneck because that's where your producer and consumer context is lost. But here we are able to do a lot of correlation, which can help you understand and dive deeper into it.
Cool. So thanks, folks, for tuning in. That was Sivanshu with our discussion on Kafka and messaging queue features. We would love to get any feedback on the feature, what you think about it, and anything which you think you'd like to see, what we should build next. So feel free to reach out to us on our Slack community or on our GitHub. We are always looking to get more feedback. So thanks a lot and have a great day.